Hello, welcome back to the FFPMD channel. Now I am going to discuss one problem which is related to the frictional force. That is, the question is find maximum acceleration of train so that box is in rest with respect to train. Take g equals to 10 meter per second square. The situation is shown in the figure and the coefficient of static friction is given 0.15. The situation is shown in the figure. Here is a bogie of train in which a box is placed and train is moving with some acceleration. Then what will be the frictional force on this box so that it remain in rest with respect to train but will be moving with respect to a man on the ground. Solution. Since the acceleration of the box is due to the static friction, here is shown here the free body diagram of box is shown with respect to ground. Here force of static friction is acting in this direction. Normal force of surface is acting vertically upward direction and weight is acting in downward direction. Since the body is not moving in upward and downward direction, so n will be equal to the mg. Now with respect to ground, since body is moving with acceleration a, so there must be a force, and that force is static frictional force. So we can write Fs equals to ma, and also we know that a static friction force is less than equal to Fs maximum. So we can write Fs equals to ma and less than equal to the value of Ss max is mu s into n, and we know that the value of n is mg. So putting this value, we have this imply ma less than equal to mu s into mg. Hence cancelling m with m, so we have a less than equal to mu s into g. Hence maximum acceleration a max will be mu s into g. Now putting the value of mu s and g, we get 1.5 meter per second square. This means that the maximum acceleration of train is 1.5 meter per second square. So the blocks be in rest in the bogie. Our next topic is kinetic friction. It is the friction force acting on body when it is moving. That is, when body start to move, then the friction force acting on that body is called kinetic friction. It is slightly less than limiting friction, that is maximum static friction. That is, Fk is less than Fl, or mu k into n is less than mu s into n. This implies mu k is less than mu s, where mu k is the coefficient of kinetic friction and mu s is the coefficient of static friction. Here is situation is shown in the figure. That is, when velocity is not equal to 0, then the friction force acting on the surface of the body is kinetic friction. And it is to note that friction always opposes the relative motion between the surfaces. Note, in problem, coefficient of friction is given. You have to consider it mu s or mu k according to the situation. That is, if body is in rest, it will be mu s, and if body is moving, then it will be mu k. Now see the another example. Find coefficient of static friction in terms of theta if block of mass m is just to slide. The situation is shown here. A block is resting on a sliding surface, and block is just to slide, means at present it is at rest. If we push it with a slightly with a small force, it will start to slide, but it is at rest at present. So firstly we have to solve this problem. To solve this problem, we have to take the free body diagram of block, and then we can solve it easily. Here solution is the block is in equilibrium, because block is not moving, so it will be in equilibrium. Now this block has tendency to move in this direction, so force of friction, that is a static, maximum static friction will be in this direction as shown in the figure, and the surface apply a normal force in upward direction, that is N acts in this direction, and because weight always acts vertically downward direction, so mg is in this direction, and it makes, because this angle is theta, so this angle also will be theta. Now we should decompose weight into two perpendicular component, that in this direction mg will be mg cos theta, and in this direction mg will be mg sin theta. So we here see that for in this direction, because in this direction body is not moving, so this force must be equal to this force. Similarly, in this direction body is not moving, so this force must be equal to this force. So we can get N equals to mg cos theta and Fs max equals to mg sin theta. We know that Fs max is equal to mu s into n, so this implies mu s into n equal to mg sin theta. This implies mu s into mg cos theta equal to mg sin theta. This implies tan theta equals to mu s, or mu s is equal to tan theta. Answer. So the static coefficient of static static friction between block and the inclined surface is given by this formula. Example: find the situation is shown in the figure. A body is connected, two bodies connected with a string and with a pulley. One body is hanging and other body is on the surface where kinetic friction is 0.04, and we have to take g equals to 10 meter per second square. This body or block is of 20 kg and this body is of 3 kg. It is given in problem. Now we have to find acceleration of block and trolley. This is a trolley and this is a block, so we have to find the acceleration of these two bodies, and tension in the string, and the tension arising in this string. So to solve this problem, we draw the FBD of this body and FBD of this body, and from these we can get equation, and solving this equation we can find the required answer. Now FBD of trolley, we are drawing the free body diagram of trolley. The here, because on this body tension will be acting in this direction, so here is T is shown in this direction, and this surface will apply a normal force in upward direction. So here this is acting in upward direction, and weight of the body will be acting in downward direction. The weight of body is acting in downward direction, and force of frictional kinetic friction will be acting in this direction, which is shown as Fk. Because body is moving with acceleration a, it is given in the problem. Now we can write sigma, that is sigma fx, that is net force along x-axis, must be equal to the mass into acceleration of the trolley. So here we have written sigma fx equals to ma. Now we have T in this direction, so it will be positive and this will be negative. So T minus Fk equals to ma, where m, capital M, is the mass of trolley. Or this implies T minus, we can write in place of Fk mu k into n. So T minus mu k into n equals to ma, or T minus mu k into mg equals to ma. This is the equation now. Equation 1. Now draw the free body diagram of mass 3 kg body. Here it is shown the FBD of 3 kg body. Weight is acting in downward direction, tension is acting in upward direction, and because string is inextensible, so if this body is moving with the acceleration a in this direction, then this body also will move in this direction with same acceleration, because string is inextensible. So on this body, acceleration is acting in this direction, in downward direction. So we can write the equation of motion as sigma Fy equals to m into a m into a. Now we have W minus T equals to ma. We have taken downward direction as positive, so W is positive and T is negative, and mg minus W is equal to mg, so mg minus T equals to ma. This is equation 2. Adding 1 plus 2 gives mg minus mu k mg equals to ma plus ma, or a into under bracket cap m plus m equals to mg minus mu k into cap m into g. So from this we get a equals to m into g minus mu k into cap m into g divided by m plus cap m. I'm putting all the values, given values, we get 22 by 23 meter per second square a. Now we can calculate from 1 tension T equals to ma plus mu k into mg, or which equals to m, putting the value of a, mg minus mu k into mg by m plus mu k into mg. Solving this, finally we get m cap m into g into under bracket 1 plus mu k into n by m plus cap m. This is the formula form of tension. Now putting all values, we get the answer. Finally, tension is 27.13 Newton answer. Now our next topic is rolling friction. When a spherical or circular body rolls without slipping over a horizontal plane, the motion is called rolling. In rolling motion, at every instant there is just one point of contact between the body and the plane. And this point has no motion relative to the plane. In this situation, kinetic or static friction is zero and the body should continue to roll with constant velocity. But actually body experiences some friction and is called rolling friction.